Hi everyone, my name is Pradyumnn, and today we'll discuss the today's contest, which was CF Div 1 plus 2, and we'll discuss the first four problems, that is A to D. Okay, and just let me know if I am audible. Hello, hello. Am I audible? Okay. So we'll begin. But before that, I will tell you about our courses at TLE Eliminators. So if you are someone trying to level up in CP, stuck at just solving one or two problems per contest, our self-paced courses are exactly what you need. We have structured the program into four levels so that you can start from wherever you are: beginner, pre intermediate, intermediate, or advanced. All right. You'll learn the most relevant CP concepts through recorded video lectures by experienced educators, followed by carefully curated practice problems combined with guided hints and detailed video solutions that will help you explain not that will explain not just the why, not just the why, but the how also. Right. We believe in helping you build the real intuition. If you need more help, you will get instant doubt support from our higher rated mentors, so you are never left stuck. And beyond learning, you can enjoy leaderboards, progress tracking, internal contests, and PCDs to keep you motivated and consistent. Pick the level that fits your goals and start learning today. And if you are not sure which level you should pick, then you can watch this video to understand that which level you can choose. And if you want more details, then you can even watch the level specific video which will explain the course's prerequisites, outcome, difficulties, and topics, right? So just you can watch all of this. So yeah, let's begin with our contest. So today's first problem was this: Mex Max. You are given an array A consisting of n non-negative integers. However, some elements of A are missing and they are represented by -1. We define that the array A is good if and only if the following holds for every I from 1 to n minus 2. Max of AI plus 1, AI plus 2 should be equal to max of AI plus 1 and AI plus 2 minus min of AI plus 1 and AI plus 2, where max of B denotes the minimum, like the max of B. Like, I think you all might know what is max of B. So the problem actually is saying, like, okay, I'll explain the max of B as well. So let's say we have a set of integers like 1, 2, 0, and 4. Okay, then the max of this set basically means that the first non-negative integer, that is greater than equal to 0 integer, which is not in this set. So here the max for this set would be 3. Okay, so this is what max means. And what they are saying is that the array A is good if and only if the max of these three, like for every three elements, contiguous elements, max of those three have to be equal to max of those three minus min of those three. Okay, so if for every three consecutive elements, that is for every I from 1 to n minus 2, if this is satisfied, then the array A is good. And we have been said that some elements are missing, and we if we can replace them with any number, then can we make the array good or not? Okay, so basically we have been given this array A1, A2 up to AN, and we need to tell them, like, we have been given this array but some elements are missing. So like, let's say this is missing, this is missing, so they are -1, and we can replace them with any element. So we should tell them that is it possible to make this, like, array good, okay, by just setting these numbers to any of the elements. Okay, so this is the problem here, and let us solve it. Okay, so we want this condition to be true, right? That max of these three numbers should be equal to max minus min. So one thing to notice is that what can the max be? Like, max of three numbers, what can it be? So my claim is that it can be only up to 3. Like, it can be 0, 1, 2, or 3. Like, if you take max of any three numbers, let's say A, B, and C, it cannot be more than 3. It has to be less than equal to 3. Because let's say if it were more than 3, then this set would have to have like 0, 1, 2, and 3. All of these numbers would have to be in this set, right? But we have only 3 numbers. So it is not possible. So the max has to be less than equal to 3. That is, the max can be either 0, like the max can be 0, it can be 1, it can be 2, or it can be 3. So when will it be 3? It will be 3 only if like it is 0, 1, and 2. I mean in any order, right? 2, 0, 1, 2, 1, 0, whatever. But the three numbers have to be 0, 1, and 2. Then only the max is 3, right? Then when is the max 2? The max is 2 when we have 0 and 1 and one more number, that is another number which is a, which is greater than, or let's say not equal to 2. Okay, so we have two numbers 0 and 1 and a which is not equal to 2. It can be 0 or 1, or it can be more than that also, more than 2. Okay, so similarly you can just figure out that what are the cases in which the max will become these four numbers. Okay, and you will see that only 0 is possible. Like if we want that this condition is satisfied, then the max equal to 0 is only possible. Like the other things are not possible. So I'll show you why. Okay, so let's say the max is 0. Like when is the max 0? The max is 0 when all of the numbers are non-zero. Like if I have max of abc, then the max will be 0 if and only if a is greater than 0, b is greater than 0, and c is greater than 0. So if there is no 0 in this list, then the max is 0, right? But what we want is the max should be equal to max minus min, right? So basically max is 0, right, in this case. So 0 is equal to max minus min. Therefore max is equal to min. So this means that my condition is satisfied if and only if I have all the three elements equal. Like max equal to min, what? Max equals to min means what? It means that all the elements are equal, right? So if my all elements are equal, let's say a, and a, then only my max can be 0, and where a is greater than 0, right? So if all three elements are equal, then this condition can be satisfied. Okay, so that is one case where this condition can be satisfied. Okay, now one more case, that let's say max equal to 1 we check. Okay, max equal to 1. So for max to be equal to 1, we have to have a 0 in our list, right? And then the other two elements can be either more than 1 or they can be 0. Okay, so all three zeros, it is not valid, right? This is not valid because here the max is 1, but the max is 0 and min is 0. So this is not possible. Like this set does not satisfy our constraints. So one number has to be more than 1. So it has to be like more than 1, right? So what we want is max equal to, like here max is 1, max equals to max minus min, right? And min is what? Min is 0. Min is 0. So max has to be 1, right? But we saw that 1 cannot be there in this array. So that means that max equal to 1 is not possible. And similarly for max equals to 2, if we want max equal to 2, then we have to have that 0 and 1 should be there, and then one more number should be greater than 2, right? Or it can be 0 or 1 as well, but again not possible because we want 2 is equal to max minus min, and min is 0. So max has to be equal to 2. But if we have 2 in our array, then the max will not be 2. So it is not satisfied. So basically it is not possible to have max value anything other than 0. Like it has to be 0. Okay, 1, 2, and 3 cannot be there. So, and even if like if we have 0, then also all the elements have to be equal. Okay, so all these three elements have to be equal, and they have to be more than 0 as well. Like all these three elements have to be equal and they have to be greater than 0. So basically in our array, like if our array is good, then for all three elements, like these three elements have to be equal, these three have to be equal, these three have to be equal, and so on. So what does that mean? That means that all elements have to be equal. Okay. So, and okay, they have to be greater than 0 as well. They have to be positive. They cannot be equal to 0, right? So now it just boils down to, can you replace -1 with some number so that all the elements are 0? I mean, all the elements are equal, sorry. So for that, initially all the elements which are not equal to -1, let's say I have this array 1 -1 -1 1 1 -1 1 1. So all the elements in this array are equal to either -1 or 1. So that means I can just replace all of the -1s with ones, right? And the array becomes good. Okay. But let's say if I have a 2 somewhere, then of course there is no way that I can make all the elements equal. So in that case, the answer would be no. So if in my array, all the elements, like all the non -1 elements are equal and they are not equal to 0, then the answer is yes. And otherwise, the answer is no. All right. So this is what the logic is. And like in the test case, we can also verify. Let's say this is the array. So here, not all elements are not equal. So the answer is no. Then in the first test case, all the elements are -1, so we can just replace them with any positive number. So the answer is yes. And let's say in this test case, it is 3 3 -1, so we can replace this -1 with 3. So the answer is yes, right? And this fourth test case answer is no, because if we want all the elements to be equal, they need to be equal to 0, right? Because 1 is 0. But all zeros is also not possible. That is not allowed, right? So yeah, that's what the solution is. Let me just know if you have any doubt. Guessing, like I just proved what I said, that Mex cannot be 1 2 or 3. It can be only 0. If there is like 0 0 0, then the answer will be no, because that array is not good. One more time. Okay, so uh, like Akshat, what my point was is that for any three numbers, a, b, and c, if you want that the max of a, b, and c is equal to max minus min, like max of a, b, and c minus min of a, b, and c, then my claim was that the max has to be equal to 0, and a is equal to b equal to c has to be there, and they have to be more than 0, like they have to be positive. So do you get this point, or do I need to repeat this point only? That if you want that max of three numbers is equal to max minus min, then all those three numbers have to be equal. So basically max has to be positive. Okay, only this point. Okay, so let's say, first of all, max value can be what? It can be either 0 1 2 or 3, right? It can't be more than 3. It can't be 4, let's say. But why? Because if we want max to be 4, then the numbers have to be 1 0 1 2 and 3. Like we need to have at least these four numbers, but we have only three numbers, so max can be only up to 3. Okay, so now I'll prove that the max cannot be equal to 1 2 or 3. Like if it is 1 2 or 3, then this condition is not satisfied. Okay, so let's say max equal to 1, like max of a, b, and c is equal to 1. So what does that mean? That means that in our three numbers, one of them is 0, and the other two, they are not 1. Not 1 and not 1. Right? So let us write the equation that we want. Like we want that max is equal to max minus minimum. Right? And in this case, max is equal to 1. And max is something. And min is 0, right? Because we have 0 in our array. So min is the 0. So what does that mean? That max should be equal to 1. Like if we want that this satisfies, our max has to be equal to 1. But we said that we cannot have one in our array. So that means it is not possible. It is not possible to have max equal to 1. Okay. And similarly, you can prove this for 2 and 3. All right. So that's why only max equal to 0 is possible. And if you want max equal to 0, then like according to the equation was that max equals to max minus min, right? So 0 is equal to max minus min, and that means that max is equal to min, and that means that all three elements have to be equal. Okay. And also they have to be positive because max is equal to 0. Like if they are 0, then max would be 1, right? So they have to be equal and they have to be positive. Okay. So guys, just let me know your doubts. I'll be right back in 1 minute. Yeah. So I'm guessing no doubts. So I'll just show the code. So this was the code. Yeah. So I basically did like just took the input and then I made a set. Like in this set, I just inserted all of the elements which are not -1. Like basically, I just counted the number of distinct elements. So first of all, if all are -1, like there is no element which is not -1, then the answer is yes, of course, right? And if there are multiple elements which are more than -1, I mean not -1, like there is one and there is two also, then the answer is no, right? Because we want that all the elements have to be equal in the array. And then finally, um, if the element which is there, like there's only a single element at this point, right? Like if s is empty, then the answer is yes. If s dot size is more than 1, the answer is no. So basically s dot size is 1 at this point. So if that number is equal to 0, then the answer is yes. I mean, sorry, if the number is not equal to 0, then the answer is no. Then the answer is yes, otherwise the answer is no. I'm sorry. So that's the entire code. 1 second, guys. All right, so let's move on to the next problem. The problem is Mani has logged Hamid in a 1 by n grid. Initially, some cells of the grid contain walls and the rest are empty, and Hamid is in an empty cell. In each day, the following events happen in order. Mani selects an empty cell and builds a wall in that cell. Note that he cannot build a wall in the cell in which Hamid currently is at. Hamid selects a direction, left or right, and then, if there are no walls in that direction, he escapes. Otherwise, he'll move to the nearest wall in that direction and destroy that wall. Hamid is at the position of the destroyed wall after this day. For example, here we have like initially your money made a wall here. Okay, so a wall is made here. Then Hamid moved to the left and destroyed this wall. So he is here. Then money made a wall here. So the wall came here, and then Hamid moved to the right and destroyed this wall, and so he is here. Then money made a wall here, and Hamid moved to the right, and he escaped. Okay, so after day 3, he escaped. Hamid is always aware of where the walls are. Like he knows that where are the walls. He wants to minimize the number of days that he needs to escape the grid. while money wants to maximize it. Determine the number of days Hamid needs to escape the grid if they both act optimally. Okay, so this is a nice problem. Like, not that simple. Like for a div to B, it is pretty complicated. I mean, not complicated, but like there are some observations which you need to make. Okay, so what they are saying is that I think it is pretty clear that what they are saying is that they have a tunnel or something. What did they call it? Grid. Okay, so I have a grid of n by 1 size, and there are some walls initially. Okay, and then Hamid is there somewhere. Let's say Hamid is here. Okay, so what he'll do is, like, okay, first of all, it is money's turn, and he can make a wall anywhere he wants in any empty cell except for the one where like this person is. Okay, so the wall maker will make a wall somewhere. Let's say he makes it here. Okay, then Hamid will either go left or he'll go right, and he'll go until he reaches the wall. Like until he gets a wall, he'll go left or right, and then he'll destroy that wall, right? And then he'll just stand there where there is empty space now because he destroyed the wall, right? And then again, the opponent makes another wall, and so on until Hamid escapes the grid. Okay, and Hamid wants to escape as soon as possible, but the wall maker wants to um, keep him as for as long as possible. So what we're trying to do is just tell the answer that what will happen. Like after how many days will Hamid escape if he plays optimally? Like if both play optimally, then what will happen? Okay. So let's say how like let's just observe some things. Okay. For that I'll need a bigger diagram. So I'll make a bigger diagram. Okay. So here, let's say the person is right here. Okay. And we have a wall here. We have a wall here. All right. Let's say we have only these two walls. And initially it is like, okay, let's say that it is currently his turn. This person's turn it is. Okay. So it is currently this person's turn, and he wants to go either right, either left or right, right. So just tell me, guys, that in this situation, if it's his turn, like okay, the wall maker made this wall, and then now is his turn. So what will this guy do? Like, will he move left, or will he move right? Just tell me, guys. Okay, he'll move left. So why will he move left? Okay, let's say you all agree that he moves left. Now let's say I make more walls on the left. Now tell me, guys, where will he move? Like in this case, where will he move? Same, left. Okay. Yes, correct. So actually, what will happen is, like if you just try to think about what is happening, like in this situation, what will happen is Hamid will move left. Okay, let's say Hamid moves left, then what will happen? Like let's say he moved here. Okay, so he broke this wall. So let's break this wall right like this, and Hamid is now here. Okay, and now it is the wall maker's turn. So what he'll do? He'll make one wall here. Then Hamid will move here, and he'll break this wall. So Hamid is here now. Then the wall maker will make wall here. and in the next move Hamid will move here and break this wall again. So this is what happens. Like as soon as he jumps here to this wall, Hamid simply, like, okay, in the first step Hamid can jump to this wall right here and break it, but after that the wall maker will just keep making these walls, like this wall, and then Hamid will come and this wall. So after the first jump, Hamid will only move at a single step at a time. Like he cannot do better. Basically, the wall maker can ensure that Hamid only moves one step at a time. Okay, so that's, like, of course that's what he'll do, because he wants that Hamid should stay in the grid for as long as possible. So ideally, the wall maker will make the walls to like to whatever direction Hamid is going, right? So like if he's going left, then the wall maker will make the wall there, and if Hamid is going right, then wall maker will make the wall just to the right. So my entire point is that after first jump, Hamid will only travel, like Hamid will only travel one step at a time, one step at a time. Okay, that's my point. So like basically we can say that even if there is one wall, like even if there is just one wall, I'm saying that, okay, this is one wall and here is one wall. So where will he move? He'll move to the left, because this one wall is closer to the exit. Like only 4 cells are here, whereas here there are 6 cells. So Hamid will move to the left, right? But even if there are more walls, then also he'll move to the left only. Why? Because in both the cases, he will only be able to jump on the first move, and after that he will only be able to take one step each. Okay, so on the first move he can jump to the nearest wall, I mean to either the left or the right wall, and after that he will move like this. Okay, so that's my point, that after the first move Hamid can only travel only one step at a time. So what will he do? Like let's say it is Hamid's move, so we can easily determine that what will Hamid do. Like if it is Hamid's turn, like here in this test case, let's say it is Hamid's turn, and he wants to either move left or right. Or let's just change the test case. Let's say I have more balls like this, here, here, and here. So if I know that currently it is Hamid's turn, then how do I check whether he will make a left or he will make a right? How do I check that? I can simply find out that what is the nearest wall. Like here is Hamid. So if he moves to the left, like he has two options, right? Either he'll move to the left or he'll move to the right. So if he moves to the left, then he'll find the closest wall to the left and move there, right? And after that, he will take one step each. So the total time taken would be this much plus one, right? And similarly, if he wants to move to the right, then he will find the closest wall to the right, and then he'll move one step each. So the answer would be this much plus one, right? So you can simply figure out that what is the nearest wall to the left and the nearest wall to the right to Hamid, and whichever one is closer to the exit. Like either this is smaller or this is smaller. So he will take that, the smaller one, because the answer is just this much plus one, like this one for the jump, right? So if it was Hamid's turn at first, then we knew that what would happen. Okay, like my point is that if it was Hamid's turn on the first move, then we would know that like then we know that what would happen. Hamid would simply uh, jump to the left or to the right, depending on what is closer to the exit. Okay, but currently in our problem, it is that the first move is made by money, right? Like money can make the first move, and he will make a wall. Okay. So let's say, like, now let's try to understand that what will money do to maximize the time. Okay. So here is Hamid, and money is there somewhere, I don't know. So here is Hamid. So either money can make the wall somewhere to the left of it, like somewhere to the left of Hamid, or he can make the first wall somewhere to the right of Hamid, right? So let's say money makes the first wall to the left of Hamid. Then my point is that obviously he'll make it here, right? Because what is the answer? The answer is that the position of the first wall. Like let's say this is the first wall to the left. Then the answer is just this distance plus 1. And since money wants to maximize that, he will ensure that this distance is maximized. So he will make the wall right here. Like if he wants to make the wall to the left, then he will make it right here. Okay. And if he wants to make it to the right, then he will make it right here. Okay. And if already there is wall right here, like let's say if already in the input there was wall right here, then making more walls to the right, like either here or here, it doesn't matter, like it doesn't really change the answer. So if there is a wall to the right, then money won't make it to the right, he'll make it to the left. And like basically my point is that money can either make the new wall to the left or to the right. And if he makes it to the left, then he will make it here. And if he makes it to the right, he'll make it here. And we can simply find out the answer for both the cases. And money will take the bigger one. Like what I'm doing in my code is that first I'm trying to put the wall right here. Okay. And then I'm finding the answer. Like what I'm finding is that what is the closest wall to the left and to the right, and what is the answer for both of them. So this plus 1 or this plus 1, right? So that is the answer for one case, like if money makes it to the left. And if money makes it to the right, then also I find out the answer, that what is the answer, either it is this or it is this. Okay. The smaller one of those, right? So I have both the answers for like both the cases, and of course money will choose the bigger one, right? So I'll print out the bigger one. So that's the logic here. So like, do you guys get some of it? I'll discuss it, like if you don't get it, but just let me know that what you guys got. Okay, happy birthday, Gaming X. Yeah, so I'll show the code. So I have this function. Like what will it do is, so this function actually returns the answer if it is Hamid's move. Like it will take in the walls, that what is the wall state, and also the initial position of Hamid. And he will determine that if it is Hamid's move right now, then how many moves will it take for him to get out, right? So what I'm doing is, first I am finding out the nearest wall to the left. So for that, I'm just making a pointer which is x minus 1, and like I am just searching for the first wall. So while s of p1 is dot, I am doing p1 minus minus, and when I reach a wall, so p1 is the wall's position. So if I move left, then the answer would be p1 plus 2. Okay, like because it is zero indexing, so the answer is p1 plus 2. So this is the left wall. Okay, and one more possibility is that I move to the right. So I'm searching for the nearest wall to the right. So p1 equals to x plus 1, and while p1 is like, well, s of p1 equal to dot, I'll do p1 plus plus. So now p1 contains the wall location. So if there's a wall at p1 and I'm moving to the right, then I can get the answer of n minus p1 plus 1. So like this is the answer if I move to the right, and I can just take the mean of that. Like because Hamid will take the smaller one, right? Hamid will make the smaller move. So the answer is the minimum of those two, and return that answer. So this function basically returns the answer if it is Hamid's move first, right? So now in my main function, what I'll just do is I will try both the moves for money. Like either money will put a wall just to the left of Hamid or just to the right of Hamid. So I'll just try both of them, and I will print out the maximum of both the answers because money is trying to maximize the answer, right? So in the first case, I just find out like the first wall, or actually this is complicated. Instead of this, you can just say that change, like what I'm doing is I'm copying this string s, the input string s, into a new string t, and then I'm searching for the first non-wall cell and making it a wall. Like that is unnecessary, but that is also fine. So I am just searching for the first non-wall and making it a wall, and that's the first possible answer. So if he sets to the right, then that is the answer. And if he, like if money makes the wall to the left, so like I am moving to the left and searching for the first non-wall cell, and he makes it to the wall and finds the answer. So if the answer, like okay, and then I just print the maximum of the answers because Hamid will choose the maximum one. Okay, sorry, not Hamid, money will choose the maximum one. So money has two options, either ans 1 or ans 2. So of course he'll choose the ans bigger, the bigger answer. Yeah, y plus 2, because like I was doing zero indexing, right? So let's say if the wall is here, like this is my string, and the wall is here, 0 index, 1 index. So the wall is at index 1. So how many moves would you take? So if you are here right now, then you would go here, right? So in one move you would go here, then the wall would be made here by money, and then you would go here. So second move, and then on the next move you will go out. So you took three moves if the wall was at 1, right? So plus 2 it is. Yeah, the code was somewhat complicated. Code was easy. Okay, that's good to know. So yeah, let's move on to C now. Rating of C, I don't know. Anyways, let's just go to C now. Trip shopping. The game is played. So there's a game which is played on two arrays A and B, each having n integers. So we have two arrays, each containing n integers. The game will last for k rounds. In one round, first Ali selects two indices I and j. Then Bahamin rearranges the four integers AI, AJ, BI, and BJ arbitrarily. That is, Bahamin can swap the numbers between two arrays, and he can also keep the two arrays unchanged. So, like these four indices, he can choose, like he can rearrange them any way he wants. So, since there are four factorial permutations, there are 24 permutations, he can choose any of them, right? So, after all the k rounds, the value of the game is defined as summation of AI minus BI. Okay. So Ali and Bahamin will spend exactly V coins during their trip. So Ali wants to spend, like Ali wants to minimize V. Ali wants to minimize V, and Bahamin wants to maximize V. So if this is a game, then we have to find out that what is the final amount of coins that they will spend if both Ali and Bahamin play optimally. Okay. So what they are saying is, we have two arrays. We have two arrays A and B, A1, A2 up to AN, and B1, B2 up to BN, right? And finally, the score of the game is defined to be the summation from I equal to 1 to n, absolute value of AI minus BI, right? Okay. And what, like there, we have two players, Ali and Bahamin, or we can say Alice and Bob. Okay, so Alice and Bob. So Alice wants to minimize the sum, minimize this value, and Bob wants to maximize the value. Okay, and what they can do is, like, the game will last for k turns. So k is given to us, and the game will last for k turns. And on each turn, first Alice will choose two integers I and j, like two indices I and j, which is such that I is not equal to j. Okay, and then what Bob can do is, Bob can rearrange the integers ai, aj, bi, and bj as he wants. Like, let's say I have these two arrays, and let's say I choose these two indices. Okay, so I have chosen these four numbers. So, like, if I'm Alice, then I can choose these two indices, I and j. Then what will Bob do? Bob will basically rearrange these integers, like these four integers, as he wants. So he can bring this one right here, this one right here, this one right here, this one right here, or something like that. Like, he can do anything. Okay, he can or he can also even keep them unchanged. Okay, so after doing this k times, and like after doing this k times, and Alice wants to minimize the total cost, like that is this is the cost, and she wants to minimize it, and Bob wants to maximize it. So what is the final cost that they will incur? Okay, so the question is clear. Okay, so the first thing that we should do is that think about what Bob will do. Like, let's say that Alice gives him two indices, I and j. Let's say this is the I and this is the j that Alice gives him. So I have AI right here, AJ right here, BI right here, and BJ. Okay, so what will Bob do if he gets these four numbers? So how will Bob rearrange these numbers so as to maximize his gain? Okay, so one thing to notice is that, obviously, okay, so one thing to notice is that, what is the cost? Cost is basically summation of modulo AI minus BI. So basically, this difference plus this difference plus this difference plus this difference, and so on, right? But when Bob changes these four indices, like when Bob rearranges them, then of course the contribution of these indices won't be changed. So all of these indices, they will remain same. Their contribution to the answer will remain same. Only, like, on this turn, I mean, on this particular turn, the contribution of these indices will remain same, right? Only the contribution of these two might change. Okay, so Bob will try to maximize the contribution of these two. All right. So, like, initially, what is it? Initially, it is BI minus AI, absolute value, plus BJ minus AJ. Okay, and finally, if Bob rearranges them, then it can change, right? So how do we, like, figure out that what will Bob do? We can do that by plotting it on a number line. Okay, like, let's say, I'll just take an example. Like, I'll just put some numbers in here to explain. So let's say I have 1 here, 3 here, and 4 here, and 6 here. So these are the four numbers initially. which Bob can rearrange. Okay. So initially, what is the answer? Like, what is the cost? It is 3 minus 1 plus 6 minus 4, right? Which is basically 4. 2 plus 2, which is 4. So can you actually draw it on a number line? Like, let us just draw these 4 numbers on a number line. Okay. So let's say we have 1 here, 3 here, 4 here, and 6 here. Okay. So initially, what is it? Like, initially the answer is 3 minus 1. That is this length right here, and plus 6 minus 4, this length right here, right? Because these two are paired and these two are paired, correct? But what Bob can do is he can change the pairings. Like, he can just change the pairings arbitrarily as he likes, right? Like, here currently 1 and 3 are paired and 4 and 6 are paired, but Bob can simply change the pairings as he likes. So let's say he chooses 1 and 6 to be a pair, okay, and 3 and 4 to be a pair. So in that case, what is the like, how much will it cost him? So like, initially I am drawing it with the green. So like, initially it is green, okay. So this is the initial length, which is 2 plus 2, which is 4. And finally, what is it? Like, if 1 and 6 are combined, so this is 1, like 6 minus 1, and then we have 4 minus 3. So as you can see clearly, this interval, like, it is clearly more than this interval, right? Like, as you can see that these two lengths come here also, like, they come here also, but the middle one comes twice, right? So that's nice. Like, that's what Bob can do. He can simply choose to pair the first and last one and the middle two ones. So in that case, he will get this extra thing, right? Like, if initially it is disjoint, like if initially the intervals are disjoint, then if Bob changes it like this, like first and last and the middle two, then he will get more length and he will get more cost. And since he wants to maximize the cost, this is what he will do. Okay. So if initially these two intervals are disjoint, then Bob can do that and he'll gain some cost, he'll gain some value. But what if initially these two intervals were not disjoint? Like, it is possible, right, that initially in our initial array only these two intervals were like this. So in this case, what can Bob do? Like, this was the initial one, initial two intervals, which I'll draw in green. So this is the length, like, okay, and they're overlapping right here. Okay. So in this case, can Bob actually make it better by repairing? Like, initially the pairs are what? These two are the pairs and these two are the pairs. So can Bob actually improve the answer by repairing these? So if he tries like this, let's say if he tries like this, then what is the new interval length? Then it will be like this plus this, right? These two are pair and these two are pair. So as you can see that in this case also, the answer actually doesn't change. So like, you can see here that even in this case, the answer did not change. Like, this segment right here is twice, here also and here also, and this segment is once, here also and here also, and this segment also is only once, here and here. So basically, Bob cannot really make it better. Okay. Like, initially if they're intersecting, then Bob cannot really make it better by rearranging or repairing them. But if there are disjoint intervals, then Bob can definitely make them better, right? So till here, guys, just let me know if you get it. That what will Bob do if he gets the two indices I and j? Then what will Bob do on his move? So do you guys get it until here? Manas, what did you say no to? Okay, I think you might have said no to can Bob make it better? Okay, so yeah, that's what Bob will do. My entire point was that if the interval I and interval j are intersecting, then Bob cannot do anything. Like Bob can't increase the answer, can't increase the answer. And like if they are not intersecting, if they are not intersecting, then he can increase the answer. Then he can increase the answer by making them intersecting. Like if they are not intersecting, then he will increase the answer and make them intersecting. So by making them intersect. Okay. So that's what Bob will do. So now just ask yourself that what would Alice do? Like she wants to choose two intervals, right? She wants to choose two intervals such that Bob Bob has to do something with them, and he can do anything with them. But Alice wants that the answer is minimum, like as low as possible. So what will Alice do? What will Alice do? So my point is that okay, if the two intervals that Alice gave, if they're intersecting, then definitely Bob cannot increase the answer. The answer will remain the same. And if they are not intersecting, like if Alice gives Bob two intervals which are not intersecting, then Bob can increase the answer. So why would Alice give non intersecting intervals? Like of course Alice would give. So Alice would give intersecting intervals. Intersecting intervals. Okay. And if she does that, then Bob can't do anything. Bob can't do anything. Okay. So this is what Alice can do. And therefore the answer cannot be increased. Answer cannot be increased. So whatever is the initial answer, that would be your answer only. Right. But there is one little flaw in this logic. And guys, what is the flaw? No, not k. Like you can simply choose two every time, like the same two every time. No, not non-intersecting. You choose intersecting ones. If you choose non-intersecting, then the answer would be maximized. But Alice wants to reduce the answer. So Alice will try to choose intersecting intervals so that Bob cannot increase them more. Like whatever the answer is till now, that will remain. Like of course it cannot be decreased. Bob won't decrease it. But you as Alice have to ensure that Bob cannot increase it. So you will select intervals where intersecting so that Bob can't increase. Like do you guys really get it? What my point is that Alice will give intervals which are like this or like this so that Bob cannot increase the answer. If she gives the intervals which are like this, then Bob will definitely be able to increase the answer, and that is not very good. Okay, Alice will Alice would choose the one which has minimum difference. Yeah, Indra Das Reddy. Yeah, exactly. The logic is incorrect in that case if all the intervals are non-intersecting. Okay, so like if the input that they have given us is like this, like this is one interval, this is the other interval, another interval, interval. So if they have given us like this, then we have a problem. What is the problem? That Alice cannot really choose two non-intersecting intervals, right? Because, sorry, intersecting intervals. Like in this case, what I'm saying is Alice would ideally like to choose intersecting intervals. But if all intervals are non-intersecting, non-intersecting, then what will Alice do? What will she do? So like she has to give some interval which is non-intersecting, right? Like she has to give two intervals which are not intersecting, and then Bob will definitely increase the answer. But that is inevitable, right? So now we have to like make sure that the amount by which the answer increases is minimized. Okay, like now we figured out that the answer will be increased, right? Alice didn't want that, but it is inevitable. So Alice will try that the amount by which the answer increases is minimized. So she will give such two intervals such that the increase in the answer is minimized. And like, how will she do that? So to get that, let us think about how much the answer increases when Bob does his thing. So like when Alice gives Bob two intervals which are non-intersecting, like let's say this red interval and green interval. Let's say Alice gave Bob these two intervals. Okay. Then whatever Bob does, like what Bob does will is this. Like he will make this one interval and he will make this interval. So initially it was this and finally it is this. So how much did the answer increase? How much did the answer increase? By this much, right? Like whatever length is this into 2, like this also and this also, right? Because this part was there initially also one time, and after, like this part also, it was both initially and finally one time. So the answer will increase by this much and twice, because this part and this part, they are both extra. So this length, like let's say this interval was a1 comma a2, and this interval was b1 comma b2. So in that case, the answer would increase by 2 into b1 minus a2, right? So Alice will find out two intervals such that this difference is minimized. And basically, what is this like quantity? You can visualize it also. Like if we have two intervals like this, then whatever the gap is between those, that is b1 minus a2, right? So Alice will give two intervals whose gap is minimum, so that the increment in the answer is also minimized. Okay, so that was like that's the entire point. So like that's what Alice will do. So that's the solution. Like if there are some intervals which are intersecting, like let's say I have this input, this is the interval, this is the interval, and this is the interval, or let's say something like this, 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 and then we have like this. So we have four intervals like this. First is this one, second is this one, third is this, and the fourth is this. So as you can see, there are two intervals which are intersecting. So Alice will just keep giving these two intervals to Bob, and then like Bob cannot do anything, right? So the answer will just remain the same. And yeah, one more thing, like if in our input all the intervals are non-intersecting, then Alice will have to give two intervals that are non-intersecting. So like let's say Alice gave these two, right? Alice gave these two. Then what will Bob do? Bob will convert them into this. Like Bob will convert them into these blue intervals, like this one interval and this two interval. So Bob will convert them into this. And then what will Alice do? Alice will just keep giving these two intervals, like this interval, this interval. So now Bob cannot do anything. So like in one turn, whatever increase Bob did, Bob cannot do more. Okay. So Bob will just keep, like Alice will just keep choosing these two intervals, and Bob cannot do anything. Okay. So that's the entire solution here. That if you have in the input n into intervals which are intersecting, then the answer is just the default answer. And if all the intervals are non-intersecting, then Alice will give the two intervals with minimum gap. And of course, the two intervals with minimum gap will definitely be adjacent. Like if we have some intervals which are non-intersecting, then any two intervals with the minimum gap would be like adjacent only, right? Like either these two, or these two, or these two, and so on. So of course, if you want the gap to be minimum, then you will choose adjacent, right? So what you will just do is you will just sort the intervals according to the first, the starting index. Okay. And if for every interval, like the next one starting index is more than this one's ending index, then we will see that it is non-intersecting. Like I'm just talking about implementation here. Implementation. So what we'll do is we will sort the intervals by left coordinate or by lower limit, right? Then what we'll see is, like, let's say the interval is of the form ai comma bi. Okay. Then if b of I, or sorry, a of I plus 1, that is, if for every pair of intervals this a of I plus 1 is greater than b of I, if a of I plus 1 is greater than b of I for all I, then all the intervals are non-intersecting, right? So we will choose the minimum value of a of I plus 1 minus b of I, and we will add to the answer 2 into that, right? And if there is an index for which a of I plus 1 is less than equal to b of I, so that means there must be some intersection like this. And then we will just keep spamming these two intervals, right? And so that makes sense, right? So I hope you understood this. Like, just let me know. Do you guys understand the problem? Okay, very nice. So yeah, I'll just code it right now, because in the contest my logic was pretty tough. Like my code was pretty tough. So I will just code it right now in front of you guys. Okay. Like since I am thinking of these as intervals, I'm just making sure that the left limit is less than the right limit. That is, ai is less than equal to bi. Okay. And then I'll sort this, and then I'll just check. And yeah, just find out the initial answer. So this is the initial answer. And if your v of I plus 1 dot first is less than equal to v of I dot second. That means the intervals of I plus 1 and I are intersecting. So just print the answer and return. And otherwise, like, okay, just keep track of the minimum also. And mi is equal to min of mi comma, like we want the minimum gap, right? So v of I plus 1 dot first minus v of I dot second. So this is the gap between the intervals I plus 1 and I, and we want the minimum gap. So yeah, I'll make it long. Okay, so finally just print ans plus 2 into mi. Okay, so this is the solution, and I hope it is correct. Like, I'll just submit it right now. Okay, it is incorrect. Let's see what I did wrong. Do you guys notice anything wrong? A can be greater than bi. Yeah, it can be greater than bi, but like it doesn't really matter because in the formula is like, formula for cost is ai minus bi absolute value. So even if we swap ai and bi, it won't change the answer. Typing speed, I guess 70, 80 around. But let's figure out what is the problem in this. I think there's a big problem because the answer is 101. Here it is 312. How is it so bad? Okay, I did not see in K. That's the problem. Because I forgot to see in K. 8, 9, 30, 16, 312. Okay. I hope it is fine. Yeah, it is accepted. Very nice. So that was the code. Just let me know if it is clear, or do you guys need anything more from me? I'll just show the code. This is the code. Just let me know. Okay. So I hope it is fine. So let's move on to D. It is called whatever it is called. I don't know. So Heartfall River runs horizontally through Destiny Land and divides it into the northern and southern sides. Engineer Root wants to build n houses along the river, numbered from 1 to n. All houses on the northern side and all on the southern side must lie along straight lines parallel to the Heartfall River. There will be m bridges, with the ith bridge connecting the house ui and house vi, where ui is not equal to vi. It is guaranteed that all n houses are connected by these bridges. That is, you can travel from any house to any other house by crossing bridges. Also, there are no two bridges connecting the same pair of houses. Root wants to know how many ways there are to arrange the n houses along the river, modulo 109 plus 7, such that the following condition hold. For every bridge, the two houses it connects lie on the bridges do not cross when drawn as straight lines between the houses. Two arrangements are considered different if at least one of the following conditions holds. There exists a house. Okay, basically they're telling that when would you consider two arrangement are different. So basically the order is different, right? So yeah, what they're saying is that we have n houses. Okay, we have n houses. Let's say, okay, let's say we have, basically we have a river in our town, and we have n houses, and we have planned that there will be m bridges. Okay, and the ith bridge will be from ui to vi. Okay, so there are m bridges, and the ith bridge is from ui to vi, and they are saying that all of these houses are connected via bridges. So like you can move from any house to any other house using the bridges. Okay, and what they're saying is, um, there are two conditions. The first condition is that any two houses which are having a bridge between them have to be on the opposite side. Okay, all right. So like this, and so this is not allowed. That two houses, let's say one and two, if they have a bridge, then they can't be on the same side. It is not allowed. Okay, and one more condition is that when you are like drawing the bridges like this, then they can't cross each other. Okay, so like they're saying is, like what they're saying is that any two houses, like when you arrange the houses like this, let's say I have 1 2 3 4 and 5, and there are bridges like this, like between 1 and 3 there's a bridge, 1 and 4, 1 and 5, and 2 and 5. So if you have these four bridges, then they are saying that they cannot overlap. Like this bridge, this bridge, this bridge, and this bridge cannot intersect. Okay, so basically you cannot, like if you try to arrange it as 3 3 5 4 and 1 2 1 2, then definitely it is not allowed. Why? Because when you draw the bridges 1 3, 1 4 and 1 5, and 2 5, so as you can see that these two bridges overlap, so it is not allowed. Okay, so just count the number of arrangements which are possible of the houses. Like it is not decided that where you would put the houses, but you have to decide that. Okay, so how many ways there are to decide that? That is the problem. Okay, so any comments until now? Bipartite and leaf node counting components. Yeah. So okay, let us try to solve this problem. Now guys, there are multiple observations here, and like I'll just state them one by one. Okay, so the first thing is that, okay, it is a graph problem. It is a graph problem. Like basically we have been given a graph, and we have to do something about it. Like we have been given a graph, and we have to like arrange the houses, right? Basically this is a graph, right? These are the nodes, and these are the edges, right? So it is a graph problem. Okay, the second observation is that the graph the graph needs to be bipartite. So what does that mean? If you all don't know, bipartite means that basically you need to divide it into upper and lower, so that every bridge is between upper and lower. Like that's what we have to do in this problem, right? And that's the definition of bipartite. Like if you have a graph, let's say like this. Okay, then it is not bipartite, because you cannot divide these nodes into two sets such that every set, like every edge, connects a node between the two sets. Like if you try, basically what bipartite means is you need to color all of these nodes either black or white, and every edge should connect um, the two nodes, like one with black and one white. Like every edge should be between black and white node. So here, if you try to color it, like let's say if you color this white, then of course this edge has to be good. So you have to color this black. So these two edges are good. So you have to color these white. But then you see that this edge is not good because it is connecting two white nodes. So therefore, this graph is not bipartite. And like similarly, you can, like, it is pretty easy to see that if the graph is bipartite, then like if a graph is not bipartite, then you cannot divide these into upper and lower, because basically white means upper and black means lower, let's say. So if you keep these three as upper and black as lower, then there's a bridge between these two upper houses, right? So this graph is not bipartite, and therefore it is not possible to make the bridges. So the answer is zero in this case. Like they are asking for the number of arrangements, right? So it is zero. Okay. So yeah, the second observation is that the graph has to be bipartite. Okay. Then the third observation is that the graph needs to be a tree. Needs to be a tree. Like basically, what I am saying is the graph cannot have any cycles. That is, the graph can't have any cycles. Okay, and why is that? I think it is pretty easy to see. Like, let's say we have a graph which has cycles. Like, this is upper, this is lower. I have a node which is here. Let's say that node has one bridge like this. Then this node has one more bridge like this. Then this node has one more bridge like this. And then there is a bridge between this node and this node also. Like, there is a cycle, right? Then, of course, there is no way to, like, make it, right? Of course, you cannot twist the bridge. It has to be a straight line. So if you have a cycle, then obviously it is not possible to make these bridges without overlapping them, right? So the graph cannot have any cycles. If it does, then the answer is zero. Okay. So yeah, that is one more thing. So the graph has to be a tree. So basically, we have a tree. We have a tree, and we need to determine that what is the number of ways to arrange it. Okay. Now, actually, the way to solve this problem is actually just to try try many test cases and just see that what is happening. Okay. So I tried many test cases during the contest, and I realized some things which I'll tell you. Okay. So one thing is that, okay, we have a tree, right? So let's draw a sample tree. Let's say this is a tree. Okay. So I will define a term. Okay. I will define a term called leaf node. Leaf node is what? Leaf node is a node with degree 1. Degree only 1. Okay. So basically all of these nodes, like this one, this one, this one, this one, and this one, they are all leaf nodes. Okay. So my point is that leaf nodes are pretty irrelevant. Okay. I mean, for the purposes of making the map, like for the purposes of whether or not we are able to make a map, the leaf nodes are pretty irrelevant. And like, why do I say that? Because, like, let's say you have this tree and you have these leaf nodes. Like, I'll just number these. So let's say this is node number 1, this is 2, this is 3, then we have 4, 5, 6, 7, and 8. So my point is that if you are able to make that pattern of bridges, like if you are able to arrange the houses which are not leaf nodes, like if you are just able to arrange these three houses, then you will definitely be able to arrange the leaf nodes as well. Okay. So like, let's say I try to arrange these three non-leaf nodes. Okay. So let's try to do that. So let's say I have a 1 here, then a 2 here, then a 3 here. Okay. So you have arranged these, and then you can simply arrange the leaf nodes. Like with 1 we have 4 and 8, right? So where can 4 and 8 be? They can be here only, right? Like the two leaf nodes can be only here, because otherwise they will intersect the this edge, correct? So they can be here. So this is the leaf node 4 and 8. Then with 2, what we have, with 2 we have this 5 and 7. So of course 5 and 7 have to be here, like this. So 5 and 7. So of course they can be 7 and 5 also. Like this can be 7, this can be 5, but they both have to be here. And these two also, they can be 8 and 4 or 4 and 8. And this 3 we have 6. So like this. Okay. So this the leaf nodes, they are just extra. Okay. We can simply add them at the end, and their position are also fixed. Okay. So let's focus on the non-leaf nodes. Now my point is that if the non okay, I have one more claim. So fourth observation, if a non-leaf node, if a non-leaf node has a degree more than 2, then the answer is 0. Okay. So my point is that if there's a non-leaf node and it is connected to more than two things, then the answer is 0. Like, why do I say that? Let us see by example. Okay. So let's say this is a node which has 3 degree, that is more than 2, and all of these 3 nodes are not leaf node. That is, I have one more node with them. Okay. So yeah, this is the like most busy example, right? That I have this node connected to three nodes. So like, these 4 are the non-leaf nodes. These 4 nodes are non-leaf node, and like this node has degree of more than 2. If we just count the non-leaf nodes, okay, I'm not counting the leaf node in the degree here. Like here in the degree, I'm only counting leaf node. I'm only counting non-leaf nodes. So like, if there is a non-leaf node whose degree is more than 2, where degree is only counting non-leaf nodes. So like, let's say if I have this, so this is fine, I'm not counting this, but I'm counting these 3 because they are non-leaf. Okay. So if I have more than 3 degree, I mean more than 2 degree, that is at least 3, then the answer is no. So why do I say that? Let us just draw a graph. Like, let us just try to draw the bridges for this configuration. Okay. So how do I draw it? Like, I'll just draw it right here. So I have a tree like this, and this node is problematic because it is connected to more than 2 non-leaf nodes. Okay. So what will I draw? Like, let's draw this. So let's say this node is number 1, and I draw 1 here. Then they have 2, 3, and 4. So let me draw 2. Let me draw 3. Now, where do I draw 4? Uh, where do I draw 4? Let's say I draw 4 right here. So I draw 2, 3, and 4. Now 2, 3, and 4 are connected to some other nodes which are 5, 6, and 7. So 2 has 5, then 3 has 6, and 4 has 7. So 4 has 7. But now what about 3? 3 has 6. But where do I keep 6 now? Where do I keep 6? I can't keep 6 anywhere, right? Because basically the point is that it is stuck in the middle. Like this 3 node is stuck in the middle of these two, this 4 and 2 and 4. And therefore I can't really connect one more node to this 3 because it is stuck in the middle. And let's say if it was a leaf node, like let's say if this 3 was a leaf node, then I could just keep it in the middle and it is fine because it doesn't need to get connected one to anything else. Okay. But since I have more than 3 things which are not leaf nodes, therefore it is a problem. Okay. And therefore the answer is 0. So like the entire idea here is that if sorry, the entire idea here is that if you have a node which is connected to like some nodes, so you draw it like this. Let's say you draw these 4 nodes. Then I'm saying like the entire point is that these 2 nodes cannot have more successors. Like these 2 nodes cannot have more adjacencies because you cannot really put those nodes anywhere now. Like if this node is connected to somewhere, you can't really put it anywhere. So um, every node must be connected to at most 2 non-leaf nodes. Okay. So my point is that every node, every non-leaf node must have a degree of at most 2. Okay. So what I'm saying is just ignore the leaf nodes right now. So like if you have a tree, if you have a tree like this, then what I'm saying is just make a new graph. I mean, just make a new tree which only includes the non-leaf nodes. So like this and this and this and this. So like you can see that all the 4 non-leaf nodes I have drawn, right? All the other are leaf nodes, right? And then if all of the degrees in that are less than or equal to 2, that is no node has a degree more than 3. Greater than equal to 3, there is no node. So as you can see, this is 1 degree, this is 2 degree, this is 2 degree, and this is 1 degree. So since all the nodes have a degree less than equal to 2, I can draw them on the bridge. Okay. And it's like if I have a tree, if I have a tree with all degrees less than equal to 2, then that just means it is a straight line. It is a straight line. Because to have something other than straight line, like anything else, it will definitely have at least one node having more than 3 degree, like something like this. If this is not there, like if the structure is not there in the tree, then definitely it is a straight line like this. Okay. That's my point. You can like try some examples to convince yourself that if all the degrees in a tree are less than equal to 2, then a straight line. Okay. So basically if you just remove all the leaf nodes and in the new tree all the nodes are in a straight line, then the answer is possible, and otherwise it is not possible. Okay. Now all that remains is to find out the number of ways to arrange that. Okay. Like until now we just identified either 0 or non-zero, but if it is non-zero, then how much, how to calculate that. So currently we have a tree, of all, like, of non-leaf nodes, which is also a straight line. Like, basically it is a straight line. Okay. So if I have a straight line and I want to arrange it on this bridge, then it is pretty obvious how to do that, right? Like, if I have a straight line like this, let's say 1, 2, 3, 4, and 5, then obviously I'll start from somewhere, like this 1, then I have 2 on the opposite side, then I have 3 on the opposite side, then I have 4, then I have 5, like this, right? So they are the all non-leaf nodes, and any leaf nodes connected to them, you can simply connect them like I told you. Like, let's say if I have any leaf nodes connected to 1, like this, then I'll just connect them right here, right here, and right here. Like, it is the only position that they can be. Like, they have to be behind this 2. So all these 3 leaf nodes, they can only be here. But the only thing that you can do is you can arrange them. Like, you can simply arrange them in 3 factorial ways. I mean, if there are 3 leaf nodes with 1, you can arrange them in 3 factorial ways. Similarly, let's say if there are two leaf nodes with 2, then you have to connect them here, right? You have to put them here. So you have to arrange them in 2 factorial ways, right? So my point is that for a given arrangement of the non-leaf nodes, like, let's say you have arranged the non-leaf nodes. Okay. Let's say you have arranged the non-leaf nodes. Then um, the number of ways to arrange the leaf nodes is just the product of factorials. Like, let's say if one has k1 leaf nodes, if 2 has k2 leaf nodes up till k5. So there are 5 non-leaf nodes and they are connected to these many leaf nodes. Then for a single arrangement of these non-leaf nodes, you can arrange the leaf nodes in k1 factorial into k2 factorial up to k5 factorial times. So this is for a single arrangement of these non-leaf nodes. But actually, in how many ways can you arrange these non-leaf nodes? Like, one way is this, right? 1, 2, 3, 4, 5. But there are more ways. Actually, there is one more way where you can simply reverse it. Like, you can do okay, I'll draw it. Like, you can do basically 1, 2, 3, 4, and 5, right? This is one way. And then two more ways are that you can flip this, like, just flip this vertically along this mirror. Okay. So basically just bring 1, 3, and 5 below, and 2, 4 to the above. And similarly you can flip this one as well. So you will get 4. Like, you will get 4 arrangements of this non-leaf nodes, and among that you can multiply this quantity, right? So you will get the answer. But actually, just there's one edge case, that if the non-leaf node part, like, this is the non-leaf node part, right? This 1, 2, 3, 4, and 5, it is non-leaf node part. Let's say its length is just 1. Like, let's say my tree is something like, okay, so in this case the non-leaf node is just 1. Like, this thing is just the non-leaf node. So in that case there are only 2 possible ways, right? Not 4. Either one is above or one is below. Okay. And similarly, if I have only 2 nodes in my non-leaf node part, let's say like this 1, 2, and let's say one is connected to some nodes 3, 4, 2 is 5, 6. So you can see that this 1 and 2 are non-leaf node. So now also there are only 2 ways. Like, either you put 1 here and 2 above, or you put 1 above and 2 below. Okay. So if I have only 1 or 2 nodes in my non-leaf node part, then I have only 2 ways And if I have more than two nodes in my non-leaf node part, then I have four ways of arranging the non-leaf node part. And multiply that by the number of ways to arrange the leaf nodes, and you will have your answer. Okay. So is it clear, guys? Yeah, 4 into that if the non-leaf node part is big enough. So guys, just let me know if it is clear. Big fan Subrata Mehta. Same to you, Surat bhai. Big fan आपका भी. Just let me know if it is fine. Okay, I hope it is fine. So again, I'll just code it right on the spot because my code during the contest was pretty messed up. Okay, so I'll code it right now. So let's do that. I have the number of nodes, number of edges, and of course the graph is connected. So if like we want it to be a tree, right? We want it to be a tree. So if n is not m is not equal to n minus one, then just print zero. Okay. So now we have a tree, and basically just look at. Okay, first of all, let's take the input. So vector of int, or yeah, adjacent of n. What happened to this? Okay, yeah. So we took the input, and then we will find a degree. So like let's say I basically defined the degree of v to be adjacent of v dot size. Okay. So now what I'll do is I will find out that what are the non-leaf nodes. Okay. So I'll make a new adjacency list, like vector of. Basically, I am making a new tree, which is it's a new adjacent, which will contain all of the non-leaf nodes. Okay. So if degree of I is one, then it is a leaf node, so we won't include it in a tree. Percent of I. So I will just iterate over all the adjacent, like all the neighbors of I, and if degree of x is not equal to one, then new adjacent of I dot pushback x. Okay. So this new adjacency list will store my new tree, right? And my new tree has to be a line, right? So basically the maximum degree has to be 2. So like what I'll do is for int I equal to 0, I'll use plus plus. If the degree, or if new adjacent of I dot size is greater than equal to 3, then my non-leaf node vertices are like not a straight line, right? So I'll see out 0. Okay. So at this point I know that this new adjacency is a straight line. Okay. And also I'll just count that how many vertices are there. So int count equal to 0. And yeah, so I'll just do count plus plus if I'm including it. So now I'll do long answer. So if count is greater than 2, then the answer is 4. else the answer is 2. Like initially, I'm just doing this and then I multiply the degree. Like I'm just doing this thing where I told you that the number of ways to arrange the non-leaf nodes. So if I have more than two non-leaf nodes, then the number of ways is 4. And if there are only one or two nodes, then the number of ways is 2, right? And then for every non-leaf node, I will just count that how many leaf nodes are there adjacent to it. Okay. So for auto x in adjacency of, like, let's say I just iterate over all the nodes, and if it is a non-leaf node, like if degree of I is greater than 1, then I will iterate over all of its adjacency list. So for auto x in adjacent of I, if degree of x equals to 1, then count plus plus, or count leaf plus plus. Like I'm just counting the number of leaves. So int count leaf is equal to 1. Like basically I want to multiply this term, right? K1 into K2 up to K1 factorial into K factorial up to K5 factorial. So for all the non-leaf nodes, I'm counting the number of leaf nodes that they have. Okay. So for all the non-leaf nodes, I'm counting the number of leaf nodes adjacent to them, right? And finally, I just multiply this answer. Ans multiply equals to factorial of count leaf, right? I don't have this factorial, so ans mod equals mod, and finally I'll see out the answer. But I will store the modulo also. So long I in factorial also. So I have this factorial array, global array, and I'll initialize it in here. So factor of 0 equals to 1, and for factor of I is equal to factor of I minus 1 into I modulo mod, right? So yeah, I think this should be it. I hope this is correct. So I'll just run the code and hopefully the output will come correctly. Okay, it is wrong. Very nice. So for third test case, why is it giving 0? Let me just try to debug here. Okay. Don't laugh at me, guys, if you're doing that. Let me just debug this. Somehow it didn't even come here. Wait. Okay. Okay, actually, what I have to take the input as well, right? So, like initially, I think the mistake is that I am taking. I was not taking the entire input. That's why it was giving the wrong answer. Now it is giving runtime error. Why is that? I think it is just because of some input error. Uh, A4 and B3. Like, why is that happening? This is weird. Wait. So input format is nm and the number of like c in nm and int ab c in ab, right? So what's happening? Someone might have commented. Okay, so this is fine. So why did this take 1 and 2? What's happening? Okay, that is the input, right? 1 and 2. Okay. Ah, my bad. So I have to take the input m. Like they are giving m input. So even though I don't need images, but I have to take in images, right? My bad. So the entire okay, it is still not correct. Chat GPT. Okay, let's do that. I mean, I don't recommend doing this during the contest because it is not allowed. But after the contest, it is fine, I guess. Oh wait, I did count leaf equal to 1. Why 1? 0 होगा ना? So does it work now? 20412 क्यों आ रहा है यार? 1 2 1 3 3 4 3 5. So basically two nodes, right? Let's see. Guys, I think like if you are watching the recording, then at this point you can just leave because after this nothing is going to be done. I'm just trying to debug my code here. Okay, actually, no, it is fine. So here answers 2 initially. So will the answer be 2? 1 2 1 3 3 4 and 3 5. So the leaf nodes here are 2 and 3. I'm sorry, 2. Okay, 1 3 3 4 3 5. So 1 and 3 are the non-leaf nodes. 4 and 5 are the leaf nodes. And 2 is also a leaf node. right? 1 and 3 are non-leaf. Okay. So the answer is given to be 8. But I am saying that it is 4. Why am I saying that? Guys, do you get the problem? No one is here apparently. So ChatGPT is saying that this should be uh, equal to. Let us just try to submit that. Okay, it is correct. So what we did wrong was that if we have two internal nodes, that is non-leaf nodes, let's say 1 and 2, then I said that the number of ways would be uh, like 2 only. So I'll do 2 into factorial of, like, basically if I have some leaves, like let's say 1 is connected to a leaf 3, also a leaf 4, and 2 is connected to a leaf 5 and a leaf 6, then I said that the answer would just be the number of ways to arrange these. So like two ways, either one above and two below, or two above and one below. So two ways into the 2 factorial ways to arrange this 3 and 4. So 2 into 2 factorial into 2 factorial. Okay, so this is 8. But it is wrong. It is wrong because I have, like, let's say I have this one below and two above. But since there are only two nodes, so I have two more options. Like either I can put 5 and 6 right like this, 5 6 like this, and sorry, not 5 6, 3 and 4 like this, 3 4 like this, and 5 6 like this, right? Or I can do the reverse, or I can do like 5 6 here and 3 4 here. So since there are only two nodes, it is possible. But in more than three nodes, you have only one option. So that's what the edge case that I was missing. So yeah, that's the entire thing. Yeah, it worked, but it did not give the correct logic though. Like I don't know, like it did not explain why we are choosing the base factor of 2 if we have count equals to 2. Let's try to ask him. Yeah, okay. It is giving the correct answer. Anyways, it never gives the correct logic. Yeah, hopefully, like I hope that were true, but it does. So, anyways, this was the PCD. If you have any doubts, just let me know. Okay, so I am guessing that you have no doubts. So I'll just end the stream and I'll eat something. So see you guys next time. What was my rank? It was pretty bad. My rating probably fell. So it was 1100. My rating was, I think it would fall by 20 or 30 points. Yeah, 27 points. Anyways, doesn't matter really. Gemini 2.5 Pro. I mean, that's like saying that um, APJ Abdul Kalam sir made nuclear missiles. I mean, he made missiles. So uh, that was to like promote war, but that doesn't make any sense. Like, of course, Gemini 2.5 Pro can be used for cheating, but it has so many other good users as well, and it's up to the students that what they want to use, how they want to use it, basically. But yeah, anyways, let's just end this. I hope you all understood. Bye bye.